Hello students, myself Nimesh Prabhakar. Welcome to Process, Dynamic and Control lecture series. In my previous lecture, we discussed about the time constant and temperature control scheme. Now, in this lecture, we discuss about the endpoint detection, then we discuss about the sequencing, logic control, and last we discuss about the pH control. So in this lecture, we mainly focus on three topics. First one is endpoint detection, then next one point is sequencing logic control, and the last one is pH control in the reactor. So without wasting time, now we start. We start with the endpoint detection. So first of all, one question comes in our mind. What is endpoint detection? So the answer is endpoint detection is an emerging technology that addresses the need for continuous monitoring and response to advanced threat. In other words, we can say one could even make the argument that the endpoint detection is a form of advanced threat protection. So this is the advanced threat protection system. So it helps to increase the efficiency of system. So this is the endpoint detection system. The reliable determination of batch cycle endpoint is important for two reasons. First one is, one way to increase plant productivity is to reduce batch cycle time, and second is, if the reaction continues beyond the optimal endpoint, the process yield can be reduced due to side reaction. So the reliable determination of batch cycle endpoint is important for these two reasons. If one reactor is changed to the reactor in substantial access to the others, this will usually guarantee the complete conversion of the other reactor, and endpoint control is not required unless the product is also used as the recycled steam. If the reactors are fed to the reactor in the same proportion in which they react, endpoint control is required. If reactant and product are the same phase, that means liquid to liquid or gas to gas, the endpoint is usually determined through the use of analyzer such as the pH unit. So when the reactant and product both are in the same phase, that means reactor is also liquid and product is also liquid, then the endpoint is usually determined through the use of analyzer such as pH unit. Now, on the other hand, we can say when the reactants are in a different phase, that means product and the reactor both are in the opposite phase, that means product is liquid and the reactor is gas, then the endpoint can be controlled on the basis of level or pressure. Now we understand this by help of this figure. If product is liquid, the endpoint control is based on pressure. See here, this is the one reactor In this, we give two reactants. One is in the form of gas and second we give in the form of liquid. See, in the upper portion is indicate the reactant is the form of the liquid, and the lower portion is indicate the reactant is the form of gas, and we get the product in the form of liquid. Now, when this pressure rise, that is an indication of excess gaseous reactant accumulation in the reactor. In response, the pressure control will lower the gas flow. Thereby, it will increase the liquid reactant concentration by increasing its relative flow. This in turn will increase gas consumption and the balance will be re-established and the control endpoint maintained. So here we can see when the product is liquid, then how endpoint detection is maintained. Now, on the other hand, we discuss here, this is the second figure. Here our product is gas. See here, same figure that we discussed in the previous section. That means two reactants. One is in the form of liquid and another reactant is in the form of the gas. Now here product is changed. That means in the previous slide we discussed product is in the form of liquid. Now here the product is in the form of gas. So as shown in figure, if the product is gas, the endpoint is maintained by the level controller. Now we discuss about the sequencing logic controls. To illustrate how sequence steps are derived for PDC sequential logic, let's look at the sequence of the event required for a common household task like brushing your teeth. Now we discuss the sequence of brushing our teeth. So first one step is what? First one step is of course grab your toothbrush. Then second one step is grab your toothpaste. Then next one step is put some toothpaste on the toothbrush. Now next one step is put the toothpaste in your mouth. Brush your teeth with the toothbrush for 2 minutes. Now next one step is remove the toothbrush from your mouth. Next one is rinse your mouth out with water. Rinse your toothbrush with water, and last one is put your toothbrush away. So this is the sequence of our household like a day-to-day work. That means here we understand sequence by help of the brushing our teeth. So that type of sequence is also followed in the controlling system, like in the reactor controlling sequence. A batch reactor control system is a combination of analog and discrete control function supervised by procedural control logic. The discrete control provides the capability to turn things on and off, and procedural control serves to initiate and step to the various processes based in a logic sequence. Now we discuss the step of sequential and logic control system in a reactor. First one is operate on-off device like pumps, vessels and so on. Next one step is active or deactive control loops. Third one step is open and close cascade loop. Now next one step is supply control loop parameter such as set point, RAM rate alarm limit, tuning parameter and flow integrals. Now next one step is integrate flow. Then after initiate time or delay between the processing step. Then perform calculation, that means performance calculation. Then next one is compare value, measurement and test indicator and batch according to the result of comparison. Now next one is initiate alarm status or operator messages. Then release control if nothing more can be done until the next sequencing interval. So these are the sequences steps for the reactor in the industry. So this is the step for the sequence. This is a step of sequence of controlling system. Now we understand this sequencing step with the help of this batch reactor or the example of batch reactor. So here in the figure you can see the upper portion of the illustrate show the physical equipment involved, including 9 control devices whose status are being logically sequenced. And the lower portion of the illustration identify the sequence process status. During the process step A, the required quantity of raw material A is being charged. The prerequisites for the initiation of the state A are that 1 and 4 be on and 6 be the off. So this is the prerequisite for this process. Now this means that agitator must be on. One, that means agitator must be on and the vent valve must be open and the drain valve must be closed. When these prerequisites are satisfied, state A initiate by turning to on. This means that the charge valve of reactant A is open and a control loop such as that shown in figure is activated. This required quantity of these ingredients is set by the receipt as QA. When the target is reached, process state A is terminated and process state B is initiated, which then perform its own task defined by the sequencing logic. In a more sophisticated reactor control system, the number of control devices and the number of logical sequence steps is much greater, but the basic concept is same. So this is the example of batch reactor sequencing logic. Now we discuss about the last one topic. This is the pH control. So the pH control in reactor is very much important. So you can see this is the scale of the pH. So first of all question come in our mind, what is pH? So the answer is pH is a measure of how acid, basic water is. As this diagram shows, pH range is from 0 to 40, with 7 being neutral. That means 7 is the neutral value of pH. pH less than the 7 are acidic, while pH is greater than the 7 are alkaline, or we can say as a basic. That means in the water, if pH level is less than 7, then that water is known as the acidic water. And if the pH level is greater than 7, then is known as the basic. Now, this is the simple diagram of measuring pH or controlling pH in reactor. So here, pH control system consists of 3 equipment. First one is pH probe. Second one is alkaline delivery system, and third one is acid delivery system. So you can see this is the diagram of pH control system in reactor. So in between them we can see here this is the pH controller. So if in the reactor that means the acid is increased, then that means the pH level is decreased. So at that time it can be controlled by acid pump turn on and the pH control is maintained. At the same time, if pH level is increased, that means pH level is decreased, then we increase the alkaline pump turn on and pH is controlled. So this is the pH control system. You can see the pH is controlled by adding the acid and basic in the reactor system. So this is a simple block diagram of controlling of a pH. So this is the pH control system. So in this lecture we discuss about the first endpoint detection system. Then we discuss about the sequencing logic control, and last we discuss about the pH control system. So this is the reactor, chapter number 4, reactor, and in this chapter we discuss the main important topic of this chapter. Thank you.